All right, kind of putting it all together now. Compositions of isometries. Okay, so we remember an isometry is when the size and shape, it's a transformation when the size and shape remains the same. So we're talking about rotations, reflections, and translations. The size and shape stays the same. It makes it an isometry. Okay, we talked about what a composition was before. A composition is when you do one transformation and then another one, a composite. There's two put together, or it could be three. It could be two or more. All right. So it's more than one transformation done at once. We've talked a little bit about this symbol, this O symbol. It's a midline O. So when you see something like this right here, reflection in the x-axis of a rotation 90 degrees of the point 23. That's how we would be read. Okay. That's how you would read this right here. Okay. All compositions are performed from right to left, so you always work from inside out. All right. So here's kind of how it works. So this one right here that we just talked about, the format would be you would start with the point 23. Start with the point 23. The first thing you would do is the rotation 90, because that's what's on the right. Always do that first. All right, so to rotate 90, we know our coordinate rules, right? We did that in our last lesson, our coordinate rules. Okay, so for our coordinate rule, or not last lesson, but a couple lessons ago, we've been using them though. Our coordinate rules for rotation 90, we flip-flop the 2 and the 3. All right, so it becomes 3, 2. All right, but then we move one quadrant counterclockwise. So from the first quadrant to the second quadrant, that's going to make the x value become negative. So it's going to be negative 3, 2. It's going to change the sign of the first thing. So basically, the rotation 90, just flip-flop the numbers and then change the sign of the x. All right, and then from here, we want to do now our reflection over the x-axis. So now we're doing the reflection over the x-axis of this point. All right, so now reflection of the x-axis using our coordinate rules, you just change the sign of the y, so our 2 becomes a negative. So it's going to be negative 3, negative 2 would be our final answer there. Okay, so some examples here. We're going to do one fully on a graph, and then the other ones we're just going to use the coordinate rules. So given the points A, 3, 3, and B, 7, 4, perform the composite transformation reflection x-axis of translation negative 8, 0 of AB. So it's this first, and it tells us what to do. Plot 3 3s and add 7 4, the originals. Okay, so 3 3 and 7 4. 1 2 3 4 5 6 7. 1 2 3 4. All right, so that's A and B. All right, and it doesn't look like a B. Okay, and then do the translation. Okay, so a translation with a vector negative 8, 0. Negative 8 is the x, 0 is the y. So negative 8 left. So subtract 8 from the x. Or move it just 8 to the left, right? So 8 to the left, 1 2 3 4 5 6 7, 8 to the left. 1 2 3 4 5 6 7, 8 to the left. There is B prime and there is A prime. And again, that's after our translation. You should connect those because it is a line segment. Okay, there's our translation of negative 8, 0. 0 means you don't go up or down. All right, so A prime is at 1 2 3 4 5, negative 5 3. And B prime is at negative 1 4. Negative 1 4. All right, and do the reflection over the x-axis now. So reflect over the x-axis. So we are 3 up, so we're going to go 3 down. We are 4 up, so we're going to go 4 down. A double prime, B double prime. Boom. All right, so A double prime is negative 5, negative 3. Just change the sign of the y. And b double prime, again, -1, -4. Just change the sign of the y. -1, -4. A little vocabulary here. This is actually called a glide reflection. You might hear glide reflection. Not sure if they're using that in a Common Core or not. I haven't really seen it on an exam, but you may see the term glide reflection. So a glide is kind of like a translation, right? And then a reflection. So think of a glide like a slide, right? A glide reflection, a translation, and then a reflection. That's all a glide reflection is, okay? So it's a composite transformation. That's a translation, which is a slide, and then a reflection. All right, this is a glide reflection. As you can see, it slides over and then flips over the x-axis, okay? All right, and now we're going to do it without the graph, because we know our coordinate rules. Okay, so first thing we're going to do is reflect over the y equals x line. So I'm going to take point P, -2, 7, and we are going to reflect over the y equals x line. And what we do there is we just switch the x and the y. So that becomes P prime. That becomes P prime 7, -2. Then we're going to rotate 270, okay, about the origin. If they don't put origin, it means origin. And we're going to do it for this point right here, 7, -2. So the rule for that is, oh, I lost my pen. What happened? Okay, we're back. All right. So 7, -2 is in the fourth quadrant, right and down. So this is in the fourth quadrant. Rotation 270 is going to be 3 quadrants around. So instead of the fourth quadrant, it's going to be in the third quadrant. All right, so we're going to go flip-flop, flip-flop, flip-flop. It's going to go, so it's 7 and 2, right? It's going to go 2, 7 for a 90, then another 90, then another 90. So it's 90, 90, 90, right? So 7, 2, 2, 7, 7, 2, 2, 7. Okay, so we're going to be at 2, 7. And because we're in the third quadrant, it's negative, negative. So remember that rule for the rotation 270 was you flip-flop them and you change the sign of the y. Okay, so that 7 becomes -7. All right, this one here, rotation 90 of a rotation 180 of point P. So we're going to start with point P. And this is P double prime, by the way. Now we're starting with P at 2, -3. And we're going to do a rotation 180. Okay, and that gives us P prime. Now, rotation 180, flip, flip. Okay, flip, flip. It's like 2 reflections. Flip to 3, 2, flip back to 2, 3. So it's going to be 2, 3, but instead of being positive, negative, it's now going to be negative, positive. Okay, so it's -2, 3. This is in the fourth quadrant. A 180 takes it to the second quadrant. Think of it like that. Then do a rotation 90. Lost my pen again. That's super annoying. Okay, and rotation 90. And this is going to be P double prime. And that you just take your -2, 3, flip-flop them, becomes 3, 2. And then we change the sign. The -2 stays the same, and we change the sign of the new x value, which is -3. So it would be -3, 2. What is the image of P -4, 6 under this composite transformation? All right, so P -4, 6. You have to do the reflection y-axis first. Reflection y-axis first. That's just change the sign of the x, so that becomes 4, 6. Then we got to reflect over the y equals x, and that's going to be P double prime. Remember, y equals x reflection, just switch the x and the y. Don't do anything with the signs. So 4, 6 becomes 6, 4. There you go. This one here, we have the point A, 3, -1. we have to do reflection in the x-axis first. That means you change the sign of the y, so a prime. Well, this is supposed to say a prime prime. Okay. A prime would be just change the sign of the y because we're reflecting over the x-axis, so it's going to be 3, 1. And then a translation 2, 5. A translation with a vector of 2, 5. All right, for a double prime. 2, 5, well, that means you take the 3 and we add 2. 3 plus 2 is 5. And we take the 1 and we add 5, and 1 plus 5 is 6. So a double prime would be 5, 6. And last one here, we have a 3, 5. And we're going to do this composite transformation. We're rotating 180 first. And remember, for rotation 180, it's 290, so you flip back. So it's going to stay 3, 5. But instead of the first quadrant, we're now in the third quadrant. Change the sign. So for 180, you just change the signs. Rotation 180, just change the signs. That was our coordinate rule. Now we're doing reflection over the x-axis of this guy. Reflect over the x, you change the sign of the y, and so the -5 becomes a positive. This will be a double prime, and we're changing the sign of the y, right? So it's -3, 5. -3, 5, and that would be the reflection x-axis of the rotation 180 of point A. See you in class tomorrow. You're going to do a bunch of these on your own in the group work section. See you then.